you? I'm glad that you tuned in today. Thank you very much for joining us. I'm Emily and this is Kelly and we are the Theory of Curiosity. Today we're going to go over the second part of allergies with you. And what I'm going to talk about is the actual allergy reaction today. So the actual allergy reaction starts with, of course, the sensitization reaction, which I explained in the last segment, and I hope that everybody understood what I was talking about. I understand what I'm talking about, but that doesn't mean that everybody else does.
Most of it went over my head, but I caught some elements of it.
Right. Well, you know.
Some you win, some you understand.
If you weren't such a stupid bitch, maybe it would be easier.
I have accepted my state of being.
Oh, I love it. Okay. Can you believe that we're actual friends in real life? Probably not. Anyway, so as we went over last time, this is the IgE, which the B leukocytes produce. And they attach to something called the mast cell, which a lot of people call, you know, the jerk cell, the allergy cell, whatever they want to call it. It's very, very important that we have these mast cells anyway. I'm not sure if during the last segment, if you built up a hate for the mast cell, but the mast cell is our friend. He's important in a lot of things.
They're important to the immune system.
Exactly. And allergies, basically, what I equate allergies to is anxiety a little bit. It's an overreaction to something that's not as big of a deal as the body thinks it is. Yeah. So that's basically anxiety in a nutshell, right?
Negative feedback loop.
Totally, which is not super necessary and not super useful. But keep in mind that all of these reactions I'm going to talk to you about are very useful in regular immunity. And that's why we have these reactions. That's why they're built into our body. That's why we've survived as a species for so long. You can't just get rid of them. That's just not how it works. The allergen comes in for the second time. Let's say it's the second time, theoretically, it could be the 50th time, whatever. The time after you've been sensitized to it. That's what I'm saying is the second time, okay? Yeah. So it comes in and it attaches to these IgE cells. Now, what happens when enough of these IgEs are connected to allergens? So basically, say that there's an allergen here, and here, and here, and here, and here, and here. Okay, so there's a bunch of allergens all connecting these IgE branches. Yeah. Okay, so that will send a signal, and I don't know what the concentration is for a mast cell. It probably differs from person to person to person. But if there's enough of these allergens that have attached to these previously made IgEs on the outside of the mast cell, then they cause something called a degranulation reaction. So
I'm assuming these have a tipping point where, like, if it's just one, it's okay, but if there's like 10, for example, 10 out of 10, then it's like, oh my god, I need to like degranulate.
I need to react to this. Yeah. Yeah. And basically what the body thinks it's doing is, I need to react to this foreign body that is threatening my health. That's what it thinks it's doing when it gives you an allergic reaction, okay? So it causes something called a degranulation reaction, and the degranulation reaction causes something a little bit like this. Okay, so it actually, it kind of barfs out. It's a little bit of a degeneration of the cell. So it actually opens up the cell and creates, and there's a bunch of chemical reactions that happen inside the cell before this happens. Yeah. It basically creates an entire string of things that occur within the cell, etc., etc. And one of those things.
So are these individual particles, or is it all attached as one?
Those are individual particles.
And they're have
all different chemicals. They all have different jobs.
Okay.
Okay, it's really complicated. It's not just histamine does this and that's it. However, the one that we're going to concentrate on today is histamine, because obviously that's easy. Easy. Okay.
It's still like, I'm very terrible with biology. Like,
he'll get better. Yeah. It's okay. So so what happens during the degranulation to histamine specifically is there's something in our cells, in these mast cells specifically, but in a lot of our cells called histidine. And histidine is something that just exists there normally. I
never heard of histidine.
Yep. It's something I think it's an amino acid, I'm pretty sure. Yeah. And it exists in our cells anyway. It has a purpose for sure. So what happens is it actually goes through a process in the Golgi apparatus of the cell and turns it into histamine. And the histamine is what causes the inflammatory reaction, okay? There's a million other chemicals that cause the inflammatory reaction as well. Again, we're just talking about histamine. So the histamine gets histidine gets made into histamine and then gets degranulated and put into the system.
Yeah.
Histamine floats around the system and it has specific ports or specific receptor sites on the tissue that it connects with.
Yeah.
Okay, so histamine goes out and it attaches to histamine receptors on the cells that it affects. The receptors go from H1 to H4. I'll only talk about H1 mostly today. H2, interestingly, is what you have on your gastrointestinal tract. So H2 receptors are what gives you food allergies.
Oh, okay, I see.
Yeah. Okay. So H1 receptors are what give us our normal, generally thought of as allergy symptoms. Okay, so the sneezing and the coughing and the hives and all that lovely stuff that we love to have happen every day. Okay, so
if you remove those receptors, what would happen? Or like permanently block them?
if you permanently blocked them, we wouldn't have as much of an immune response.
Oh, okay.
Unfortunately. Yeah, so it's not a super.
So it's part of the signaling system?
Yeah, so what it causes when it actually attaches to these histamine receptors, each one specifically, is it causes an inflammatory response, okay? So the inflammatory response that histamine incites includes vasodilation, which causes the capillaries to become more dilated.
Oh, okay.
The reason it wants to do that is because it wants to make it so that white blood cells actually travel more easily across those barriers and can get to the affected tissue.
How would dilating it make it easier?
Well, because the cell membranes, the walls, like the walls and the capillaries block them from coming out all the time.
Yeah.
So histamine opens those up so that there's areas where they can actually go through and attack the tissues.
So it opens up a space in the membrane.
It does, yeah, exactly. So what it does, it makes it so it goes through this membrane, it dilates your capillaries. So the side effects of that are the runny nose. It makes it so that there's more fluid going back and forth, right?
Because the fluid is coming through that opening.
Exactly.
I see, and water molecules are small, so they go through easily.
Exactly. Whereas white blood cells are actually quite a bit bigger. So they're gonna let these, it's like saying a HEPA filter is going to trap viruses. It's not. Okay, it's not ever gonna do that. Like, viruses are so small, and especially when you're talking about, you know, HEPA filters taking away dust mites. Dust mites are like
a million times bigger.
A million times bigger
like
than viruses.
Several scales of magnitude.
Yeah, so when people think that HEPA filters take away, I know this is an aside, but when they think that it takes away that, they're wrong.
Yeah.
So, again, please keep in mind that your body is trying to protect you against bacteria, viruses, external antigens that are actually really going to hurt you, and this is an overreaction of that. The inflammatory response causes vasodilation, which is intended to give you white blood cells to the actual affected spots.
But makes everything's runny as well.
Exactly, makes everything runny. It also causes, it also stimulates the sensory neurons in the areas that it affects. So it causes the sneezing and the tickly throat and all that kind of stuff. So it causes that, which actually is a really useful part of it, because if there was a bacteria in that particular realm, then the physical extraction of that through sneezing, through eye watering, through coughing is actually really useful, because the physical extraction of it is a big bulk of our immune system. So that's the part of it that is really, really important. So it's like, I'm getting these sneezing reactions, that sucks, but actually it's a good thing, kind of, not in the realm of allergies though. Okay, so it causes that. It also causes bronchial smooth muscle contraction, which causes the coughing. Another thing that it does is it's a chemoattractant though, and that's one of the main thing that it's so good for. So it's a chemoattractant basically means, say I'm histamine and I'm attaching to something that it needs to be helped, right? Or something in the area that needs to be helped. I have my megaphone and I'm like, hey, white blood cells,
Oh, okay.
come over and help a brother out, you know?
So
Like,
it's a signaler.
it's a signaler. It makes it so that neutrophils and stuff are actually attracted to the site so that they can come and take care of that problem.
Yeah.
So that's what histamine does. That's the general overview of what your allergic reaction actually is, and how you can't really get rid of it without, like, you can't just get rid of all of it without messing around with your entire immune system.
It's not like a surgery that you can cut out some organ.
No.
Yeah, fair enough.
So, anyway, I hope that was interesting. I hope that was informative. The next one will be about antihistamines and what the differences are and what the chemicals are and stuff like that. So that should be très interesting.
Awesome.
Anyway,
Thank you.
have a good one.
Yeah, have a good day.